I'm standing on a fire trail in Strawberry Canyon. Behind me, the black box you see is the molecular foundry, 96,000 square feet of construction. The university and the national laboratories are planning to build close to 1 million square feet of new construction on this site. They also want about 500 new parking spots dedicated for what they expect would be close to 860 new employees. All of this is planned for Blackberry Canyon, just above this hill, and above, immediately above, Hearst Avenue, its houses, its dormitories, and a main part of the campus, as well as Strawberry Canyon on this side, which is immediately above Hearst Greek Theater and the Memorial Stadium, as well as residences and dormitories.
I'm Garnis Curtis, Emeritus Professor in the Department of Earth and Planetary Science at the University of California, Berkeley. As a letter I wrote to the regents, I emphasized that there should be no buildings in either Strawberry Canyon near the stadium or Blackberry Canyon. And these are the reasons why. The geologic setting is this. Here is the active Hayward Fault. Here is the Wildcat Canyon Fault. And between them, once 10 million years ago, was a volcano. That volcano erupted violently and made a big cavity in which this whole area collapsed to form a great void. The outlines of the western margin of that void is here, from the Botanical Garden northward several miles, and includes all of these buildings resting on material that collapsed into the void we call a caldera. In working with Shively and Ben Leonard concerning slides at this location here on Long Centennial Drive, and this location over here which threatened these buildings to the west, we found that we were in volcanic rock in clay matrix which was sliding as water moved it. In this caldera, filled with debris from the old cone, it left great cavities between large blocks of andesite which collected water. And that water was gradually seeping out and causing these landslides. And unless they pumped that water out some way, we would continue to have slides in this caldera material. A horizontal hole of drill did not relieve the water, but when a vertical hole was put down, a well here, it bumped into one of these cavities filled with water, and over the next 10 years, 16 or 14 million gallons, I think 16 million gallons of water are pumped out. East of the Hayward Fault here are Cretaceous sedimentary rocks, older than 65 million years. These are dipping westward at 20 to 30 degrees. This caldera is like a great big tub of mud with no rigidity to it at all, and much heavier than water, pressing against these Cretaceous beds, dipping westward. The U.S. Geological Survey has made extensive studies of the Hayward Fault and find that the return time on earthquakes going back to the time of Christ is about 130 years. The last major quake on the Hayward Fault was 1868, 140 years ago. In short, it's overdue. If an earthquake occurs when these beds are soaked with winter rains, the chances of a major landslide are great along the slippage plains of shale dipping westward toward the campus. Buildings in the lower parts of both Strawberry and Blackberry Canyon would be buried if not destroyed. The buildings on them will certainly move a few feet in a major earthquake, if not hundreds of feet. No major buildings should be built on the hills or canyons above the campus.